loud because the battery's not working so great. Don't tell me it's not working at all. I can't see that there, it's moving. So I'm going to talk louder than normal tonight. I don't want to, but I want you to be able to hear it at least. I put a new folder in here too. It's called Endocrine Lab, and I will just show you that it also has, in addition to our handout, or something that's very close to our handout, it has PowerPoint that you've already seen last week, and it has this other handout. This other handout, Lab Handout 2, is a description of every slide that we went through. It tells you where to find it in the textbook, and it talks about the PowerPoint that I used and the PAL CD. Do you guys remember PAL? No? Did I talk about it last week? That's where I'm starting tonight. You're going, PAL, I don't have a CD called PAL. Well, that's okay, because we made a deal with the publisher to get it on our website. If you purchase the package, you've already purchased the rights to it. Okay? And you guys have all purchased a big package or something. So you will go here and you will click PAL 2.0 right there. And it's exactly the same as the CD, except it's online. And we figured we'd make it easy for you. Let's make it the same user ID and password as Course Compass. You remember what the user ID and password is? Synapse Lab, Synapse. You get a screen like this. You just click on the icon right in the middle of the page. And then it opens up this really cool program. They have taken images of real dissections of humans, of models, and of slides. Cat and fetal pig, which aren't really relevant to us, but they could be if you wanted it to be. I would say, first off, let me show you how the models work. Easy model to start with. You'll just open it up, pick the system, pick an organ. I always go to the self-review first because I like the way it works. Look, if you roll over something, it highlights that whole structure and names it. That's so much better than I could do by using 500 words to describe a picture, because I would go, well, the border of that article is somewhere over there, and it's somewhere it goes over, you know, you can just roll and see. Boom, right away. Ventricle, other auricle, the rest of the atrium up there. Once we do the heart, that'll make more sense. You know, we haven't done the heart yet. But you can see how easy that makes it for certain things. So let's leave that, and let's go to histology, and let's go to endocrine system. That's cool. That's all right. Yeah, I heard it. What's that look like? Pretend you can't read. See how it's got two sides to it, right? We're used to top and bottom, but remember, it doesn't matter how they put a slide on. Top, bottom, left, right, bottom, top, right, left. You know, they could put it however they want. Two sides to it. One here, one here. So cool how it highlights it once again. That will help you tremendously if you use this. What kind of tissue is this side? And this one? So let's pretend I'm giving you all the information you need on the pituitary. You need to know that the gland is the pituitary gland, that there's two parts. What are the two parts? Right, anterior and posterior. And you need to know the fancy name for both of those, don't you? Which are? Right, adenohypophysis and neurohypophysis. And you need to know which hormones are produced in each region, correct? Okay, here it is. Name the hormones produced here. Who said none first? Raise your hand. 12. I heard it. Yeah. Staph. Staph. What's your name, Staph? All right, Susie. Good job. That's pretty much it for the pituitary, isn't it? I might ask you targets, you know. Name one target of this hormone, target of that hormone, or name a function of this hormone or that hormone. But as far as the slide goes, That's it. Other than, one more question. Name this tissue. What kind of tissue? How about just cuboidal epithelium instead of simple cuboidal? Because it's not actually simple cuboidal. Cuboidal epithelium, and what about this tissue? Nervous tissue. Nerve tissue or nervous tissue would be fine. Wow, look, they zoomed up right on the border between the two here. And you're barely seeing any, but you can totally see cuboidal cells versus long, skinny fibers. So that's nerve tissue, and that's cuboidal epithelium. Don't worry, my scopes don't go that tight. Aha! Next slide. I'm just going to go in order that they have them here. Right, that's a pancreas. That's a pancreas. And a pancreas has this big thing called? Right, watch this. Boop. So cool, isn't it? Islet of Langerhans. That is the endocrine portion of the pancreas, the islet of Langerhans. What is this tissue, all of this out here? Exocrine and pancreatic acini. Correct. It's called the pancreatic acini, and it's the endocrine. Sorry, exocrine. Heard that word come out of my mouth. That's not right. Exocrine part of the pancreas. Name the hormones produced here. Where the pointer is. Okay, so no hormones, right? This isn't the hormone part, right? I'm evil. All right. Name the hormones produced here. It's not a trick. Insulin and glucagon. Do insulin and glucagon do the same thing? They do the? So we could call them? See, if you forgot how to spell antagonist, I put it on the board for you already, because I psychically knew I would be teaching you this, since I taught this 4 hours ago. Can you think of anything else you should know on the slide about the pancreas? Okay. While you're looking at that, I'm going to go move it a little and go get something else. Just show you, just so you get a feel for this. Look on the pituitary here, that endocrine lab handout 2. On this slide, you should be able to label the following structures: anterior lobe adenohypophysis, posterior lobe neurohypophysis. And then it talks about the adeno is composed of cuboidal, neuro is composed of neural tissue. So it's got it all there for you, okay? So you have so many ways of learning the information. It's up to you which way you choose. I'm going to open up our main handout now. Where's the little X for Excel? There it is. And look, we open it right up to what organ? Pancreas. Now your lecture teacher is way behind, I've heard, because of a holiday and a snow day and a blah, 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 blah. All right? So you haven't got this far yet, but I've heard that your lecture teacher makes a big deal out of words that start with a G in this chapter. And here's why. We have this stuff called blood glucose. Tell me what that means. Perfect. Blood sugar. That's exactly what it means. However, there's also this stuff in the body called glycogen. Look over here. See, this hormone, which raises the blood sugar, breaks down that stuff. From AMP1, who remembers what glycogen is? A chain of glucose. Excellent. A chain of glucose. So this is a visual. Look up here for a second. While you're writing chain of glucose, look away. Make the words real hard to read. You got one glucose here, one here, one here, one here, one here, And honestly, it would keep going for 100 or 200 of them. What happens when this hormone breaks it down is it does this. It chops between the two, and it frees them. So you get individual glucoses now. They're no longer part of a chain. When they're free, where can they go? To the blood. And it does what to blood sugar? Raises it. Raises it. So glycogen is a chain of glucose molecules. Anytime you break it down, it likes to go into the blood, so you raise the blood sugar. That's how it works. Can you see how it would be very difficult if you forgot the difference between glucose and glycogen to know what's going on there? Real important words there. Oh, but that's not enough. Name the hormone that breaks down glycogen that raises blood sugar levels. Glucagon. Can you see if you change the spelling by one letter, it messes it all up because these words are so close. And I will tell you in lecture, I will add gluconeogenesis, glycogenolysis, and glycolysis. Other G words that have gluc and glyc. So you got to learn exactly what these two are, glucagon, and then when I add those others later, it won't be so confusing because we didn't add it all at once. All right? Cool. PAL. Oh, it's already hiding on there somewhere. There it is. So back to PAL. 2 down, 20 to go. Hey, look here. What are those? That's a longer horn. Notice how they're not hollow, right? You see that thing right above this that I'm pointing at? See how it's hollow? Right up there? I don't want to roll over it, though. See that one? There's one right there. And there, see there's one over here? Watch. Those are ducts. They could also be blood vessels depending on what's inside of them. Ducts or blood vessels. Don't be fooled. Those are not islets. How would you know they're a duct or a blood vessel? They're hollow. How would you know if it was a blood vessel instead of a duct? Hollow, empty. It's got a hole in it. See how this one's got a hole right there in the center? See how there's no hole in this one? It's nice, solid. That has a tube, a hole, tube. Okay. Here's how you know. If it's got red blood cells in it, it's a blood vessel. So when we're looking at pancreas again later on, maybe at some time in your reviewing, and after we've seen blood and you know what blood cells look like, then you'll be able to see them on every pancreas slide inside of a blood vessel. Okay? So I'll use that to help you later on. What's all this tissue? What's the name of this stuff? What's the name of it, though? Now, what kind of tissue? Pancreatic acini. Pancreatic acini. What's the name of this? Islets of Langerhans. What kind of tissue is all of this? Yeah, say it. Yeah, Keith, say it louder. Cuboidal epithelium, right? Whether it's the endocrine or the exocrine, it's all in the pancreas, cuboidal epithelium. Yes, they are. But only which one makes the hormones? Only the islets. Good. Oh, here's a pretty islet. Right there. We didn't do parathyroid. But we did that. Look how little it is. Man, if you're sitting like over on this side of the room, you can't hardly see that, huh? Looks awful on that projector. We have to figure out why that is. Is that better? Can y'all see to right back there or not? Pardon? Here, let's do this. Better? There's the colloid. And this whole thing is a follicle, right? And what are those cells? Follicle cells. Yeah, they call it follicular epithelium. That's because it's simple cuboidal epithelium. The cells are called follicle cells. It's a simple cuboidal layer, simple cuboidal epithelium. And the stuff in the middle is colloid, and the entire spherical object is a thyroid follicle. Just follicle is fine. They left something off. Name these cells. Close. Parafollicular. You know, I wish they called them that same thing because they are, you know, but they didn't. These are parafollicular cells. What do the parafolliculars make? Calcitonin. What do the follicle cells make? The thyroid hormones, T3 and T4. Give me the fancy name for T3. Triiodothyronine. How about for the other one, T4? Thyroxine. What's the other name of thyroxine? Tetraiodothyronine. You don't need to know that, though. Okay? Actually, it makes more sense. T3, tri, T4, tetra. You know, tetra means 4. Iodothyronine on both of those. So if you wanted to call it tetraiodothyronine and triiodothyronine, you could, because then you only have to learn to spell the iodothyronine, you know. You don't have to worry about the thyroxine part. But that's up to you. Any questions about this gland? Cool. Yes. What's? Oh, the whole thing is a follicle. The center's the colloid, and this is the follicular cells around here. Okay? The cells around it, these cells around here, these cells here, these cells here. Okay? The follicle cells. Look. Aha! Look, no label. Oh, wait, one. They picked one. Parafollicular cell. But that is his buddy, and there's a little cluster of them. Little family. Parafollicular family. They're so cute. Hey, you do this long enough, you got to entertain yourself. But I got a new toy. It's so cool having this in here. Oh, man, how cool is this? Capsule. Outside of the capsule would be adipose, which you can actually see a little embedded in there, can't you? Okay? Ours, we know it's separate. Look, zona glomerulosa. Look here, zona. And they did like me. They say the other layers are so bad we can't see them. Let's not show them. Right? Ain't that how we did it? They're so smart. Wow. Glomerulosa fasciculata, and what would be under it? Reticularis. Those are 3 parts of the adrenal blank. No. Cortex. Cortex. And what would even be further below that? The medulla. Not the medulla cells, but the medulla, right? The medulla. Oh, that's awful. I don't want to even see that. That's bad. I don't like those labels. Okay, here we go. Glomerulosa, fasciculata, and reticularis, which, once again, on our slide's not good enough to label, okay? I would say that's not the best slide, is it? I would say that ours might be better.
Are you telling us that we just need to know the top 2?
On the slide? Yeah, yeah, absolutely. So remember this one? Oh man, it does that every time. Fat. Ugly little fat there, photoshopped in. capsule. Now look, now I'm all bummed out because when I scroll over my picture, it doesn't highlight it. See how quick you get used to it? You're like, where's the highlight? Zona. What's special about fasciculata? It's long, perfect. What's special about glomerulosa? Spherical, circular, clumpy. I like to say clumpy. Sounds cute. It's all clumpy. What do we call clumpy fat? Cellulite. That's what cellulite is. It's clumpy fat. It's fat with connective tissue in it that pulls tight in places and lets the fat bulge in other places. See? So they've found ways now in the modern world to break down cellulite. Did you know that? It's not a lie. These new things that they have to break down cellulite work. Because what they do is they stress the connective tissue and tear it and heat it all up and they smooth it all out. And then it doesn't come back together like that. You still have fat. They just break the binding part that causes it to pucker, which is totally genetic. Some people get it, some people don't. You know, you can't help that. That's genes. All right, zona, reticularis, and the medulla. Name the two hormones made from the medulla. Epinephrine and norepinephrine. Good. Name the hormone from any of this. This name could sound like pepperoni if you're being silly. Aldosterone. See? It's not how you say it. Aldosterone comes from what area? Good. Glomerulosa. Cortisol comes from? Good. Androgens come from? Nice. The capsule's made of? What makes cellulite pucker? Connective tissue. The capsule's made of connective tissue. Oh, I forget. I'll get used to it someday. Name these cells. Good. Name these cells. Follicle cells. Name this pink stuff. What is it? I love it. Okay, it's time to teach more. See, I gave you a few new things tonight, like antagonist wasn't really new for our class, was it? But glucose, glycogen, and glucagon, focusing on the G's, was kind of new for us. This is new. Colloid is the stored form of the thyroid hormones. It is the stored form of the thyroid hormones. Did I say that to you guys? Yeah. I actually did more in your class than I did with the other classes. Now they're going to listen to this and they're going to be mad at me. So they just got some of this new today. What cells are these? Parafollicular cells. See them? That's a perfect one right there by the tip of the pointer. Thyroid hormone. Stored form of thyroid hormone. So let's think about this. This gland, this thyroid gland, has these little single layer of cells, simple cuboidal epithelium, that makes the hormone and pushes it in here to store it. And when it stores it, it's stored in a stored form, so we call it colloid. Notice we're not calling it thyroid hormone, right? Come back, mouse. So, therefore, it must be changed a little bit. It's actually bound to some other stuff while it's stored. So it's a different form. That's why we call it the stored form. The important part of this, the thyroid's the only gland that does this, that stores its hormone in a different form and stores a large supply of its hormone. No other gland does that. Stores a large supply in a different form. In fact, if your thyroid quit working today, you probably wouldn't notice it for 2 weeks because you have enough stored, maybe even a month. You know, if it was just getting a little sluggish, it would take a while to show up. because you already have so much stored in there. Aha. What organ? Ovary. Both of these are called a blank. Follicle. Which one is this? And tell me what's special about the outside. Simple squamous. Nice. And it gets thicker and becomes this layer though? Simple cuboidal, even though that picture's not. Okay. And it's called the what follicle now? And inside of both of these follicles, there's a developing what? Let's go oocyte. Okay? oocyte. Site. Man, I can't even see those arrows up there. Can y'all? There and there? Who can see them good? Raise your hand. Girls over here, can y'all see them good? Oh, you want mine? Mine are pretty bad. All right, that's the ovary. Name the hormone that the ovary makes, that the follicle makes. Estrogen. Estrogen. Name another hormone the ovary makes. Yeah. Yes. We don't have a good ovary picture, that's why, but it's back in exercise that has to do with after the reproductive system. Say 646, there you have it. You're welcome. From the class, I say you're welcome, because they were the helpers, not me. All right, next. Oh, the little testes. Let's pull them. Yes, I want to save it there. There it is. Looks like what little fruit right here? Kiwi, but what is it actually? It's a tubule. Way to go, Oz. It's a tubule. It's a seminiferous tubule, right? Because it has a lumen down the middle. Y'all remember that? The cells are spermatocytes. So you see how I can point at the same thing and ask more than one question? The cells are spermatocytes. The entire object, the entire thing here is a tubule, a seminiferous tubule. That's the difference. Name that cell, spermatocyte. Name this entire structure, seminiferous tubule. Name this hole, lumen. Name the cells in the hole, sperm. Name the cells in here, spermatocyte. Bless you, bless you. Name these cells. And what do the interstitial cells do? Which? Testosterone. There you go. Please don't say it like that when you're in nursing. Anything else you need to know on this picture? Not yet. That's it. That is your review of your endocrine slides. All of them, what you need to know on them. You are more than welcome to go back and listen to it whenever you want.